Okay, so in this video, I'm going to walk through the my programming challenge solution for assignment 2. So for the assignment 2, the task is to given a state table of a Moore machine and an input string. Use the Python as the code programming language to have a series of functions to produce the output string generated by the machine. So for my code, to easily display the data structure, which is the state table, I import the pandas as my PD module. And the example for me to test my program challenge solution, I use the question from the textbook, which is the number of the question is 13.20. So for the example, the state table has 4 columns, which show in this output form. So it has 4 states and has the input as 0 or 1, and with each one is pointed to a specific state. And for each state, it has a output generate function that has a different output string here. I will say output symbol here. Okay, so let's move on. So I randomly input a string, which is 10010001, and I also import the RE module, which for me to match specific string in my program. Excuse me. So for the program, I use the OOP, object-oriented programming paradigm, to design my logic here. So this class Moore machine has a init function, which will be called when instantiate this class here. And for this class to be instantiated, it needs 2 parameters as the input. The first one is the state table, and the second one is the input string. Those 2 parameters I already instantiated in cell 3, or not cell 3, cell 2 here, and cell 5, which is here. So for this init function, when instantiated, it will assign these variables, i.e. properties onto the instantiated class. It has a state table, it has input string. Those 2 are the same as the input parameters here. It has the states, which is the first column of the state table, the S0, S1, S2, and S3. And it has a states outputs, which is pointing to the last column of the state table, which is 0, 1, 1, and 1. It has a Gmap and Fmap. They both instantiated with initialized with empty as a empty dictionary here. The initial state, which will pointing to the first state, which will be S0. The transit state, which will be also initialized as the first state, which is S0. For this transit state, it also serves as the purpose of track each state. So, for example, when the my program reads this string, so for the first string it is 1, then the start state is S1, S0. It reads as 1, so the transit state will be S2. And S2 will be the next transition start state. And then when this program reaches the second string, which is 0, S2 will transit to S2 again. So that transit state will be served as a memory place that's storing the transition state. And it has outputs. This output is initialized as a empty list, which will be served as the storing places for the final results parsing. And the derivation table will be served as a derivation table to show how this output is generalized by this input state table. Okay, so the next function is the main function. The main function is actually the workflow function that calls all the other functions towards the final result. So the first one is a parse the state table. As we input a state table as a dictionary, my program needs to parse this dictionary into into a different data structure for further computation. So for this part, it calls parse gmap and parse fmap. So parse g, it will generate the gmap. So you remember that in that function here, my gmap is initialized as an empty list. An empty dictionary. This parse g will loop through the states, which is a list of the state S0, 1, 2, 3 in the state table, and put the state name as the key and the value of that state as the value of that the value of the output of that state as the value of this gmap. So this gmap will look like a dictionary with 4 different properties. The first property will be the key as S0, the value as 0, and the second key value pair will be key as S1, value as 1. The third key value pair will be key as S2, value as 1. The last key value pair will be as S3 as the key and 1 as the value. And then the parse f function does the similar stuff that it will generate the f map. For this function, it loops through the keys of the state table, which from this view we'll see the keys will be the state, input 0, input 1, and the g. So this function uses the RE module to match the specific any key that start with input. And if the key is start with input, it will replace the input. So it will basically strip the input from this key and also strip the dash between the input and 0. So the key for this fmap will be 0. There will be two different key value pairs. The first key is 0, the second key is 1. And for each key, the value will be a list of this column values. And the next function is a start transition. This function is actually the core function that simulates the Moore machine. So for this logic here, It starts with the initial state, which is S0, based on this state table, S0 of the initial state. It loops through the input string. The input string is a length, a 1, 2, 3, 4, 5, 6, 7 length string. For each symbol in the input string, the output will be the reading from the G map and read the value of the key as the value of the transit state. So as we start from the S1, for S1, the transit state will be pointing to S2. The value for this state is 0. So we put 0, append 0 into the outputs. Into the outputs list. And then for the index here, this index is needed for us to read from the fmap. Remember that the fmap we parsed by the parse f function. So the index will be 0 for this loop. The symbol will be 1. So basically for this one is what it's doing is here is like this. It start from S1 and put the outputs into the outputs list, and then to generate the transit state, it says that the index for this one is 0, and the key for this one, because as it reads the first character is 1. So the transit state is in the fmap is the second key value pair, which start with 1 as the key, and the value is a list of this column, and the index is 0, so it reads that S2 is the next transit state. So after this looping finished, we will get a list of outputs, and we will also get a derivation table, which these two will be further parsed as our output. The next function is the parse result, which takes the outputs list joined with empty space, which empty string, and prints out the result. The last function is display the derivation table, which it will parse the derivation table by using the panda data frame to print out the table. All right, so let me execute the cell, then we can see the output. So firstly, I run this first cell to input pandas module, the second cell to initialize the state table, which will be our first parameter, and then print out the state table as a panda data frame. Initialize input string, which will be used as the second parameter. Input the RE module, regular expression module, which will be used in my class, and there's a whole class executed. And in the cell 8, I instantiate this small machine class, which will be our machine object here. And this machine object, instead of running the machine.main, I will run there are four different functions instead of the main function. So instead of running this main function, I'm going to run each of these four functions one by one, so we can see the result directly. I mean, step by step. So delete this one. So let's first run this parse state table. After running this, we can get the Gmap here and also the Fmap here. So the Gmap is the one that a mapping for the generate function. So for this state table, it will have four different key value pairs as displayed here. For each state, it has the output number or output symbol. The Fmap is the transition function map, which is for this state table, it has two different inputs for each state. So for each state here, for each input here, it has a different transit states, a list of different transit states. So this Gmap and this map, Fmap, we use the combine them together. We can get the and also the star transition machine together. These three stuff. This is how I simulate the Mars state machine for my program. And then after we execute this start transition function, then we can run this parse results function and we get the final result of this output string. And the large function is display derivation table. After we executed this function, we get a derivation table for how this program being given the input string, which is this one. For each input, it shows the transit state for each input, and also shows the output for each transition. The first row is actually how many steps it went through. So there are totally 7 steps. Start from S0 and ended with S2 state. So if we run this main function in a whole, directly running this main function, it actually runs all the above 4 functions all together and give us this output string at the top and the derivation table below. And that's it for my walkthrough of the logic of the program.